Hello everyone, welcome to the channel. We have an interesting radical equation today. The square root of x plus square root of negative x is equal to 1. Now if x be some real number, then x should be non-negative for the square root of x be real, and the negative x also should be non-negative. Then x should be non-positive, but both non-negative and non-positive also only satisfies this x is equal to 0, but 0 doesn't satisfy our original equation, so this is rejected. Actually all real x's are rejected. Then we will think about the complex solutions. Now squaring both sides, squaring these both sides, we will have the square of the square root of x, which is x, plus the square root of the square root of negative x, which is negative x, and the multiplications of 2 times 2 again. 2 times root x times root negative x is equal to 1 squared, which is 1 again. These two cancels, this is equal to 0. So we are left with 2 times the multiplication of these two, which is negative x squared. Square rooted is equal to 1, and cancelling by 2 we have negative x squared. Square rooted is equal to 1/2. So again and lastly, squaring both sides, we will have negative x squared. Let me write here. Negative x squared is equal to 1/2 squared, which is 1/4, and cancelling this minus, we will have x squared is equal to negative 1/4. This is nice, since square rooting both sides, we will find the roots. X is equal to 1/2 times I, and the other root is negative 1/2 times I. These are two roots for our equation. Let me check for you at least one of them. Let's check the first one. To check, let's x be 1/2 times I. We have the original equation, root x plus root minus x is equal to 1. Let me check for you. Then we will have root 1/2 times x plus root negative 1/2 times x times I, is equal to 1. We want to check this actually. Now let me remind you that the square root of I is equal to 1 over root 2 times 1 plus I, actually plus or minus. This is plus or minus. Let me use this. You can use the other one also. Now this first one can be written as 1 over root 2 times square root of I plus 1 over root 2 times the square root of negative I. And we want to show this is equal to 1. Now this 1 over root 2 times 1 over root 2 times 1 plus I, and this part again 1 over root 2 times 1 over root 2 times 1 minus I. Let me write that also. So here the square root of negative I is equal to 1 over root 2 times 1 minus I. You can check these by yourself, and we want to show this is equal to 1. Distributing these two, we will have 1/2 times 1 plus I plus, again distributing, 1/2 times 1 minus I, and we want to show this is equal to 1. So we have 1/2 times 1 plus I plus 1 minus I, and these two positive I and negative I cancels. We have 2 here. 1/2 times 2 is exactly equal to 1. Then this is checked. The first root is checked. Since the problem is symmetric, the root x and root negative x we have in the original equation, the other root is also possible, since the negative will become positive, positive will become negative. We have 2 roots. Let me say this again. We have x is equal to 1/2 times I and 1/2 times negative I. Thank you for watching, and see you in the next videos.